Alright, so this is number 7 on page 263. So first of all, it tells us the region R, so we're dealing with R, and it's bound by a whole bunch of things. So I'm going to sketch the graph, which is always a fantastic thing to do when you're trying to find volumes and different things. So the first thing it says is bound by part of the curve, y equals quantity x minus 2 to the 3/2 power. Okay, so the first thing I know is if I put 2 in for x, I end up here at 2, right? Because that's going to be the x-intercept, because when I put 2 in, y equals 0, okay? The other thing I'm going to notice is that it's shifted over 2, but since my exponent is greater than 1, it's going to be going upward like so, okay? Alright, so that's that part. And then it says, and we're looking for which x is less than or equal to 2, is greater than or equal to 2, but less than or equal to 4. So basically, we're looking here for x. Okay, and okay, we'll pretend this is 4 even though it's a little crooked. Say this is 4. Okay, so we're looking between those two lines. So let's go ahead and I'm going to fill this in so I can fill this shape. Okay, oops. Yeah, okay. The x-axis, so now they're saying the x-axis is the boundary, and the other boundary line is x equals 4, which we already wrote because they already told us that. So basically, the region that we've kind of encased is this little purple region here. So basically, we know we're going from 2 to 4. Okay, on the x-axis, and since we're rotating, since it says find in terms of pi the volume of the solid obtained when r is rotated through 4 right angles about the x-axis, well, we don't need to even find this point of intersection up here, which would be really easy. We just put 4 in for x because we're just using the x-axis because we are going this way to create our circle. Okay, so there's no hole here because I'm rotating about the x-axis. So we're going to end up with an interesting shape that looks something like, if I can draw this. Okay, I can't draw it, but it's going to look something like, okay, and it comes to a pointy end here, like this, okay. Okay, it looks something like this, kind of like a cheerleader's megaphone or something. Okay, probably not as nice as that because it curves in faster and like this, but same idea. Okay, so all we're going to do is now we are going to set up our volume integral. Okay, so we're going to say pi, and we're going from 2 to 4 on the x-axis. Okay, and we need to sub in y squared dx. So basically we need to plug in this equation. Okay, and then we're going to square it. So we could do that before or as we're doing the integral, and I'm just going to do it all at one time. It doesn't matter if you get y squared first. You end up doing the same thing. So we end up with this, and then this whole thing is raised to the power of 2 because y squared. So again, it's maybe a little neater to do it before, but it doesn't really matter. You get the same result. Okay, so I'm going to simplify this before I integrate. So I have a power raised to the power, which means that I multiply those exponents together. So I end up with x minus 2 quantity raised to the power of 3 dx. Alright, so unlike number 6 that we just did, or I just did, maybe you just watched, x is to the power of 1, which means we can undo the chain rule because we know how. So I'm going to go ahead and integrate this by undoing the chain rule. So I end up with 1 divided by my coefficient of my x term, which is 1, times 1 divided by my new exponent. So we say 3 plus 1, which is 4. So put 4 down here. Times what's in the parentheses, raised to my new exponent. Alright, so that's that method. And then we're going from 2 to 4. Alright, so I'm just going to simplify this. So we end up with pi times 1/4. Okay, and now I'm going to substitute 4 minus 2 to the fourth. And now I could continue on, but if I think about this, 2 is my x-intercept, which means that I'm going to have a value of 0. So I'm not even going to bother plugging that in, because I'm just going to be subtracting 0, because anything times 0 is 0. So I'm just going to simplify this. I get pi times 1/4 times 2 to the 4th is 16, which gives me a value of 4 pi. So basically the volume of this solid rotated about the y-axis is 4 pi. Alright, so that is how you do number 7.